A laser is placed at the point 3, 5. The laser beam travels in a straight line. Larry wants the beam to hit and bounce off the y-axis, then hit and bounce off the x-axis, then hit the point 7, 5. What is the total distance the beam will travel along this path? Interesting. You know, I'm gonna do this on graph paper. Just so I can get things to be more or less to scale. Okay, so the laser is placed at the point 3, 5. That's here. And we want to go through the point 7, 5. Oh, interesting. Here. So what route is it going to take? Something like that. In fact, I think I actually just drew out exactly the path it's going to take. We're lucky none of the angles are going to be all the angles are 45 degrees, right? This path works. It bounces off the y-axis, then the x-axis, then goes through this point. Yeah, so the points happen to be chosen such that you know, everything is 45 degrees. If one of these points were sort of off line somehow, this wouldn't work so well. I feel like I'm cheating by using graph paper. And not to, so the way you would do this actually, if I want, let me do this kind of without the graph paper. In fact, let's go back to the other thing here. So here's how we do this without drawing something perfectly to scale. Okay, I'm going to draw everything on both axes here, right? So we have the original 0.35 and the other 0.75. Okay, so this is roughly the route things are going to take. So what I'm going to do is I'm going to take this point and reflect it in the x-axis so that the route the laser takes like that. Once I reflect that point down to here, so this point, by the way, is of course 7, -5. Now we can think of the laser beam as going to here, but then going through the x-axis like so. And now what I'm going to do is take this point and reflect it in the y-axis so that it's now down here, -7, -5. And we can imagine that the laser point just shines straight through like this. And so what I need, this point is 3, 5. The total distance, is that I need the total distance? Yeah. Total distance the beam travels is just the distance between these 2 points. So that should be distance is equal to 10 squared plus 10 squared square root. So that's the square root of 200, which is 10 root 2. I hope that's the right answer. And I should be able to count it a little bit more easily if I go back to my graph paper setup. So how many squares does it go through? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it goes through 10 squares, all of them at diagonals, so 10 root 2. And that's the answer. I mean, this is how I would have done it if I didn't have the technological ability to put graph paper down very easily. Nice little problem, and I guess it really just tests whether you understand that this, things traveling in straight lines that reflect is kind of equivalent going through, but reflect the point rather than reflect the path itself. Yeah, so it's a nice little problem. If I have a mistake somewhere, I'll let you know. Thanks for watching.